Yo, what's up? How is it going, YouTube? Welcome to our YouTube channel, Sir Lupheht TV. And if you're new to this channel, please do the honor of subscribing and like this video and share this to your classmates. So for today, we're going to discuss, or I'm going to discuss to you. I'm going to teach you how are you going to use this online software which is used in graphing a student's t-distribution. Okay, so before we proceed to that, let's just do some review right here. Okay, so as you can see, this is the table that we are using for t-distribution. This is what we call the t-table. Then we have here the computation of on how are we going to get the p-value. Okay, so let's begin with this one. Okay, so the p-value, or denoted as alpha, the Greek letter alpha, is used to is the one of the values that we are using in determining the t-value for a t-distribution. Now, the formula for p-value is 1 minus the confidence level, or it's simply 1 minus CL. Now, this CL is the confidence level, wherein this is used for most tests, and some values that we are using are 90%, 95%, and 98%, and with 99%. Now, for this example, I'm using 90%. So before we plug 90% into our equation or into our formula, you must convert 90% first to 0.9, or into its decimal equivalent. So 90% in decimal is 0.9, 95% is 0.95, 98% is 0.98, and 99% is 0.99. Okay, now by subtracting these values from 1, which is constant in our formula, so we'll get 1 minus 0.90. so meaning when the confidence level is 90%, or 0.9, the p-value is 0.10. When it is 0.95 for our confidence level, the p-value is 0.05. And when our confidence level is 98%, or 0.98, the p-value is 0.02. And lastly, for 0.99 confidence level, the p-value is 0.01. So these values, such as 0.10, 0.05, 0.02, and 0.01, can be found in our t-table. As you can see, those mentioned values are here. So we have one tail. This is for the one-tailed test, and then we also have two tails for two-tailed test. Okay. Yeah, so we're going to find those p-value later on. Okay, so we have discussed the confidence level, the p-value, and then the t-table. Now, in this t-table, you can also see in the leftmost column the df. So this df, as you remember, this is the degrees of freedom. So I have included here from 1 to 30, but there are higher values. But for this video, we're just going to focus with degrees of freedom from 1 to 30. And these are our t-values. Okay, so let's now proceed with our online software. So let us explore this software. So in here, we can input 3 values, wherein if we tried to input the first 2 values, this software will compute the third value. Okay, let's say for example, our p-value is 0.10. okay, or from our given, which is confidence level of 90%, we are going to compute that the p-value is 0.10, like what we discussed a while back. So that's 0.10. Now, let's say that the degree of freedom that we are using in the test is 7. So we type 7 here. As you can see, the software is already computing that the t-value is 1.895, and also it will show us the graph, okay, since we use two tails here. Now, as you can see, we have options here for two tails, right tail, and left tail. We also have 0 to t and negative t to t. So for this video, we're just going to focus with two tails, right tail, and left tail. So this options such as right tail and left tail, this pertains to the one tail in our t table. Okay, so the difference is that left tailed are negative, and then right tail is positive. Okay, so let's just use first the two tails. So if we're going to use two tails, so let's say the p-value is 0.10 and the degree of freedom is 7. The computed t-value is 1.895. Okay. Now, the graph or the curve looks like this. So as you can see, since we use two tails, we have a shaded region at the left and then another shaded region at the right. So we call this the rejection regions. And then the p is also here, 0.10 or 0.1. And the computed value t is 1.895. So as you can see, this 1.895 is read from 0. So this is 0 and then 1. And then the next number is 2. But as you can see, since the value is 1.895, it is somehow close to 2. That's why the value that we have here is, or the boundary is, it approaches 2. Okay, that's 1.895. Okay. Now the next thing that we're going to do is we are going to compare this value with the t-table that we are using. Okay, so based from our previous example, the test is two tail and then the p-value is 0.1. So that means that this is the value that we are looking for, 0.1. And then the degree of freedom is 7. It's right here. Okay, so after locating that 0.10 and 7, we're going to intersect them, and you will see that they will fall. So their intersection will be at 1.895. So as you can see, this value is the one also being projected or shown in our graph here. So the t value is 1.895 and it is also shown here. T is equal to 1.895. Okay, so I'm also helping you how to use this, so you can also understand how to graph it on your own without using the software. So the output or the drawing should look like this. Okay, so again, let's recap what just happened here. So we decided that we are going to use the confidence level 90%. So if the confidence level is 90%, we subtract 0.9 from 1 and it will become 0.10. Now this 0.10 will be our p-value, and we're going to look for that, or we're going to type that into our software. So we type here 0.10 and we decided that the degree of freedom is 7, and then we decided that the tail is, or the test is two-tailed. So as you can see, the software is already computing that the t-value is 1.895 and it will project, or it will show the graph. The curve looks like this. Now we also tried to find that 1.895 here in our t table. So the degree of freedom is 7 and then the p-value is 0.10, and we also have here the value 1.895 as our t-value. Okay, now let's try to use right tail this time. Alright, so let's say we're going to use the right tail. Okay, and then we are going to use 95% confidence level. So if we're going to use 95%, the corresponding p-value is going to be 0.05. Okay, so we're going to type it. We're going to type that into our software. So instead of 0.10, we're going to use 0.05 now because our confidence level is 95%. Okay, so 0.05. Now we're going to use also, or change the degree of freedom. Let's change this to 10. And you can see that the value now is 1.813. Okay, and the graph looks like this. As you can see, since we chose right tail, so the shaded region or the rejection region is only here at the right, and then you have the p-value 0.05, and then the t is 1.813. Now let's examine our t-table if we're going to get the same value, 1.813. Take note, it is right-tailed, so meaning that's one tail, and then the p-value is 0.05 and the degree of freedom is 10. Let's go. Okay, so we are with 0 or the one tail, and then the value or the p-value is 0.05. It's right here. And then our degree of freedom is 10. It's right here. So let's see if we're going to get the same value. Okay, so if we're going to intersect this, for one tail, 0.05 p-value, and then degree of freedom is 10, and we will get 1.812. Now going back to our software, it says that the t-value is 1.813, so we can ignore those discrepancy. 1.812 and 1.813 were almost just the same. Okay, so meaning we can use hand in hand, or we can use the software, and we can also still use the t-table. Okay, and the graph looks like this. Now let's try the left-tailed one. So the difference is just, if we're going to choose left-tailed here, you can see the value, the t-value is still 1.813, only that the sign now is negative, and you see the rejection region shifted here to the left. So the p-value is still 0.05, the degree of freedom is 10, and the t-value this time it became negative, so it's negative 1.813. Okay, so let's try another given. So for two tails again, so let's go back to our what's this? So let's say we're going to use 98% as our confidence level. So for 98% confidence level, the p-value is 0.02. So take note of this value, 0.02. And then let's go back to our software. So let's type in 0.02 here, and then let's say that degree of freedom is 17. And we will use two tails. Okay, so you will see for a p-value of 0.02 and degree of freedom of 17 for a two-tailed test, we're going to get t-value of 2.567. So take note of these values, and we're going to locate this in our t-table. Alright, so the degree of freedom is 17. It's right here. and then we are using 2 tails for 0.02. I guess that's 0.02. So we're going to intersect those 17 and 0.02. So we will have 2.567. So let us take a look at our value. So the value, or t, is 2.567. So as you can see, it's the same with the value that we got here in our table. So that's from the degree of freedom is 17. And then for two-tailed test, the p-value is 0.02, and you see that the value here is 2.567. So this is our t value. Okay. Let's try another one. So let's say we use right tail for this. Are the values going to change? Let us see. So as you can see, if we held p-value as 0.02 still, and then the degree of freedom is 17, but we change the test to right tail test, you see that the t value is going to be 2.224. Okay, so let's try to take a look in our so the degree of freedom is still 17, but we use the right tail test. So that's one tail, and then we're going to find 0.02. Okay, so in here we don't have, I guess we don't have 0.02 for one tail test, but let us still connect this. So the value is, it's around 2.110 if the p value is 0.025. Okay. Okay, so in our software, it is 2.224. so I forgot that for one tail test we don't have 0.02 in our t table. Okay, so we can we can skip that. Okay, so I guess at this point in time you already know how to use this software. Okay, so I hope you understood the steps that we have here. So as you can see, whether we don't have the t table or whether we don't have this software, we can still get the t values for students t distribution. Okay, so just follow the steps, follow the process that we're doing here, and you can never go wrong. Okay, so that's it. That's all for this video today. I hope you learned something out of this, and maraming salamat sa inyo lahat. This is Sir Lupheht, nagsasabi na sa bawat problema mayroong solusyon. Dapat tayong maging solusyon para iwas konsumisyon, dahil darating ang araw lahat ng ito magiging alaala na lang. Kaya samahan nyo ang gumawa ng magandang alaala. Maraming salamat. Hanggang dito muna. Ingat, asan ka man. God bless you and goodbye for now. Pa-like yung video, subscribe ka na rin kung bago ka lang sa ating